Very much, Simon. So yes, today I'm going to talk a bit about the display backplane and its role in driving micro-LEDs. So we've heard a lot in this conference about micro-LEDs and various other things, but not so much about the TFT. And what I'm going to talk about today is how we can use some of the properties of our TFT materials to fabricate the display in a slightly different way, which potentially has some benefits for micro-LED, particularly for large area ones. SmartKem Limited is a UK-based company, but we're a subsidiary of an American company, SmartKem Incorporated, which is on the listed on the NASDAQ stock exchange. So therefore, I'm obliged to give this kind of legal notice to start with. As I said, we're based in the UK. Our main headquarters are at Manchester, where we do a lot of our materials R&D and some device R&D and the formulation scale-up. But a lot of the work that I'll show you that's been done today in making the displays is prototyped up at the Centre for Process Innovation, which is a kind of a Fraunhofer-like institute based in the northeast of England, run by CPI. So there we have clean rooms available to process devices from materials into displays. We've also entered into an agreement with ITRI in Taiwan to put our materials onto their Gen 2.5 line, as you can see here. So that's in the process of transfer over, and that will then give us an ability to go right from kind of material research through to early demonstrator and into kind of pilot line facilities, which then allows us to springboard into manufacturing in Asia. So we have a team there in a business development office and technical support. We have other links into China with Linksil for access to the Chinese market. So the organic thin film transistor that we develop is made up of a number of materials. The only things we don't make are substrates, so we generally sort of source those in or work on glass. And the electrodes, which are generally sputtered metals, because for the resolution that we require and the quality of surface, then we have to use sputtering and photolith in order to get the accuracy in the device. But all the other layers, the base layer, which is cross-linked polymer, semiconductor layer, surface electrode treatments, dielectrics, sputter-resistant layers, and passivation layers, are all our own sort of chemistries and tuned for particular reasons to give good device performance. So these are made in and formulated in volume that can be supplied to display manufacturers in up to roughly 3.5 litre quantities in a bottle, and we can supply up to a couple of thousand litres a month if necessary. So the properties of the materials, I'm not going to go into great detail about this in this short presentation, but they have mobilities around about 2.5 centimetres square per volt second, so it's roughly kind of 3 or 4 times amorphous silicon. Very good on-off ratios, so they're very good for sort of switch TFTs as well as drive TFTs. And one of the key properties is we can process these all at very low temperatures, so even down as low as 80 degrees C, which in comparison to inorganic TFTs, which generally have to be processed at, say, 350, 450 degrees C, allows you then to form these things on quite a wide range of plastics, not just polyimides. The materials are designed to be a kind of a drop into existing amorphous silicon lines, so they're all liquid coatable and processable in air, so we can just use existing capability for spin coating or slot die coating in order to put the materials down, and then the photolith, dry etch, wet etch, etc. is already there for structuring the electrodes and alignment and patterning. So therefore, there's a minimum capital reinvestment required to adopt OTFT onto process lines, and that's gradually kind of gathering pace, as I described previously with the interaction with ITRI. So micro-LED, I won't dwell on this too long because I think it's been articulated quite well. It's the benefits of micro-LED is the brightness, the good quality, the good blacks, potentially thinner and lighter designs are available, scalability and versatility of the technology. However, there are a number of challenges in manufacturing, and I'm talking particularly here about non-AR or VR applications, which have slightly different kind of elements in the manufacturing. When we want to make kind of relatively large area displays like TV or iPad or things that will go in an automotive application, then some of the challenges are the relatively low yield of the kind of bonding process of attaching the LEDs to the backplane. and typically require things like